Hello everyone, welcome to the next video in this Data Modeling in Action series. In this session, we will be finalizing the logical data model that was created in part 1 by applying a set of data modeling standards to the entities and their attributes. In doing so, the logical data model will then be ready for its conversion to a physical design. In the previous video, we followed Walter and his fellow data modelers at the Prodatamodel company as they kicked off a project to build a new message tracker application. Their business team counterparts want to retire their while you were out paper forms, which they use to document incoming telephone and visitor messages for unavailable staff members. Since the company has grown, it makes sense to create a new tool that will help automate the capture and dissemination of these messages. So they requested the assistance of the data modeling team to help gather the requirements for a replacement solution. Therefore, Walter and his teammates performed a detailed analysis of the while you were out form and created this logical data model. Their design handled all of the data requirements and rules represented in the form. They also added relationship verb phrases to help highlight the business perspective. The data modelers then generated 30 individual business rules and presented them to the Prodatamodel business team. The review of the resulting data model in this business rules format allowed the Prodatamodel business team to quickly understand the content and give the green light to continue. Now, the modeling team gets to work on the next part of the journey. First, they will tag each entity with the appropriate data subject type before they jump into applying data modeling standards. The data subject type provides a quick reference highlighting the expected data volume growth rate, data security level, and target user audience for any future application using this data. There are 4 major data subject types utilized here at Prodatamodel Company. The top-level data subject type is control data. This type of data is used to manage system features or access to data content within the information system. Some examples are user role permissions, application security groups. The next data subject type is reference data, sometimes called lookups. These are sets of standardized values or classification schemes that are set up for common use across the enterprise. They can be managed internally or leveraged from external standards groups or outside agencies. Some examples are occupation codes, languages, internet domains, and country codes. Then there is master data. This describes people, places, things, or concepts important to the business, such as customers, employees, products, sales territories, etc. And lastly, transaction data. Transaction data is data generated from the day-to-day business events and activities, such as product sales, purchase of supplies, customer support calls, to name a few. The team starts by looking for any entity that may contain control data, which can either govern application features or content access. Message response rule fits the content control definition. This entity contains the allowable responses for a given message type. Moving to the reference data, the team notes that the entities with sample values fit the reference definition, specifically phone type, event, message type, response, and message role. Master data is next and describes people, places, things, and concepts. Both person and org fit this definition, along with some related contact information for persons. The remaining entities should match the definition of transaction data. Since message, call message, message person, and from message person all contain data about the message-taking business event, it appears correct. With the tagging of data subject types completed, the data modeling team can now move on with the review of each entity and its attributes. As a quick refresher, Walter walks through the general naming rules and guidelines with the team. We should only use singular form of a word and refrain from using any abbreviations or acronyms in our names. Qualifier words should be added to any entity or attribute name that is too general. Verify all entity names are documented in uppercase and attributes are in lowercase. Also, make sure to indicate if the attribute is required. In simpler terms, must it be added now or can it be added later? And finally, make sure there is a class word on each attribute. Let's cover a few of the class words in our glossary. For the string data type, we have code, description, flag, identifier, indicator, name, and type. For class words under the numbered general data type, we have amount, count, number, percent, quantity, and sequence. And here are some of our date-time class words: date, date-time, time, timestamp, and weekday. Oh, and let's not forget about our domains. These are the special class words that can be used as a complete attribute name. For example, the domain called email is always an electronic mail address with an expected format containing an @ symbol with an internet domain name and top-level domain code suffix such as .com. Domains can also be quantitative in nature, like the examples in the numbers domain. Notice that the unit of measure is also included in the domain name weight pound. Or the domain could be just a numeric field with a separate attribute containing the unit of measure, but both attributes would be required in the entity in that case. These domains are also part of our class word glossary. All right, with these data modeling rules fresh in our minds, let's get started. The team starts the review with the independent entities, which do not contain any foreign keys. This guarantees they will not be affected if naming updates are made to any related entities. These are considered top-level entities or level 1. In the model, there are 7 level 1 entities, 5 reference data entities, and 2 master data entities. Phone type is first. Phone is not completely spelled out, so the entity name is enhanced to telephone type. The entity's single attribute type is a valid class word, but it is too general for a name and needs to be qualified. Thus, the word telephone is included. We can easily determine the data type as string based upon the sample values, pager, fax, and cell. And since this sole attribute is the primary key, it must be marked as required. Moving on to event, the team agrees the name is too general, so they review the sample values to get a sense of how to augment the entity name. They notice that the entity isn't really going to store actual events, but only the type of an event, so it makes sense to rename it as event type. However, we are not storing all types of events like music concerts, weddings, or other social events, so it makes sense to further qualify the entity name with a message keyword, yielding message event type as the enhanced entity name. As with the previous entity, the attribute name type is a valid class word, but too general as a complete attribute name, so the team updates it as well. They choose string as the data type, which handles the character strings in the sample values, and also mark it as required since the attribute is the primary key. The next reference data entity is message type. The entity name adequately reflects the expected sample values call and visit, thus is acceptable as is. The attribute name, however, is again too generic even though it is a class word, similar to the previous entities. The team prefixes the name with the message keyword to clarify its meaning. The string data type is assigned, which handles the sample values, and the attribute is marked as required since it is also the primary key. Moving to the response entity, the team immediately sees that the name is too general. Seeing the sample values, this entity also does not contain actual instances of responses, but only a type of response. It's also clear that these responses only apply to messages, so the entity name is updated to message response type. The attribute name type is also updated to be specific as the entity name. The string data type and required indicator are added as well for this primary key attribute. The fifth and remaining reference data entity is message role. The name does seem to match the sample values from and signed. However, to confirm the meaning of the sample value from, they quickly take a look at the paper form. The from field refers to the individual who was calling or visiting. So with this understanding clarified, they now focus on the primary key attribute named role. The word role is not a class word, but seems like a good candidate as it clearly signifies the various capacities in which a person may function. Therefore, the modelers decide to mark role as a pending class word and apply the keyword message to indicate that these roles only pertain to messages. They again apply the string data type based upon the sample values and mark the primary key attribute as required to finish the update. The next entity, person, is a master data entity which stores instances of persons either calling, visiting, filling out the form, or receiving the while you were out message. The primary key attribute name is definitely a class word, but should be further qualified to indicate a person's name. This prompts the discussion about whether an update would be allowed to make a correction to the person's name. Since the possibility exists that the message taker may need to correct a name spelling or go back and add a last name, a new database process would need to be created to handle the cascading update. To avoid this undesirable scenario, the team agrees to add a new surrogate key attribute called person identifier. The population scheme for this attribute will be determined later in the physical design. Additionally, the team wants to further qualify the person name by having separate first and last name attributes. Names are definitely strings and they would be the true business key. Therefore, they are marked as required. The next master data entity is org. For completeness, the abbreviated org is spelled out. Also, seeing that the attribute called name is the primary key, the team wants to eliminate the possibility of cascading updates as with the person entity. So the team creates a new attribute called organization identifier and sets it as the new primary key. The attribute name, which is a valid class word, is updated to organization name for clarity. Finally, both organization identifier and organization name attributes are assigned the string data types and marked as required. Organization name is the true business key in this entity. Having completed a review of all Level 1 entities, the team moves down to Level 2 entities. There are 4 of them. Level 2 entities will all contain at least one foreign key from a Level 1 entity. For the person phone entity, the word phone is updated to the full word telephone. There are 2 parent entities related, telephone type and person. Both had their primary key names updated previously. Therefore, the migrated foreign key attribute names in person telephone are updated as well. And the role name from is maintained. The remaining attribute phone needs to be updated to the full word telephone, but it also requires a class word, so the team discusses this quickly. Telephone numbers are comprised of a series of digits. Also, there can be other characters included, such as dashes and parentheses. To keep it simple, we should only store the numbers and leave the formatting to the user interface. So the team selects number as the class word. To complete the update, data types and the required indicator must be assigned.
Telephone number implies a number data type, and it must be required, otherwise it won't be a valid instance of a person telephone. And the two foreign key attributes will inherit the string data type and are marked as required. Since the cardinality of both relationships are noted as 1 and 1, indicating one related record is necessary. The next entity, person email, is similar to person telephone, which also inherited a foreign key from the person entity. And since the primary key of the person entity was updated, it's also necessary to refresh the foreign key attribute in person email to from person identifier, which preserves the original role name from. The other attribute email is actually a data domain and can stand on its own. However, the team agrees adding a person prefix ensures clarity. For the foreign key attribute person identifier, the string data type is inherited and marked as required since it is the primary key. The domain email was defined as a string in the classword glossary and is also marked as required since a person email instance isn't valid without an actual email value. Message is the next entity which is at the heart of the message-taking data model. It has three related parent entities: message type, person, and message response type. All three had their primary key attribute names updated, so the new names are applied here as well, along with the inherited data types and the required indicators since their relationships show 1 and 1, meaning one related instance is required. Looking at the remaining attributes, date, time, important, and message, it appears that each one needs either a qualifier or class word added for completeness. The attributes date and time are valid class words for the date-time data type, but are too general as attribute names. Since both date and time indicate when the message was recorded, the message qualifier word is added. For the attribute named important, the team reviews the while you're out form to see its usage. It appears to be a checkbox field, which can be marked or left blank. This is a binary state and can be represented by the flag class word, which is defined with a string data type and required indicator, since it will have a default value of no. The remaining attribute message also needs a class word. The form shows this field as a comment or note area where any extra information can be recorded as part of the message. So the team selects note as the class word, which comes with the string data type. Although a note may not be recorded with the message, it was previously decided to set a default value of none to affirm when no message was provided. Therefore, it is marked as required. Before moving to the next entity, the team reviews the three attribute compound primary key consisting of two-person identifier, message date, and time for potential update scenarios. One possibility is that the wrong person name was originally associated, which may require an update. The date and time would most likely be programmatically added. Even though the need to correct the linked person may be a remote possibility, if even one case exists, then it would require a process to handle the cascading of the new primary key value to all related entity instances. To eliminate this possibility, a new surrogate identifier attribute is added as the sole primary key. The next entity, message response rule, contains control data and consists only of two primary key attributes inherited from the related level 1 entities, message type and message response type. Since the related parent entities both have their primary key names updated, it is necessary to update them in this entity as well. Also, their data types are inherited and the attributes are marked as required since they are both part of the primary key. With Level 1 and 2 entities reviewed, the team now identifies any Level 3 entities. There are two of them, call message and message person. Although message person has a relationship with a Level 1 entity person, because it's dependent upon a Level 2 entity, it automatically becomes a Level 3. Call message is affected similarly. This call message entity is comprised of foreign key attributes from the two related parent entities, message event type and message. As before, the team refreshes the attribute names in call message to match its inherited key names. The data types are also inherited, and since both relationships indicate 1 and 1, this means the one instance is always required. So they are marked as required. Similarly, message person consists of attributes from three related parent entities, message, person, and message role. This requires all attribute names to be refreshed with the new primary key names from the parent entities. Again, the string data types are inherited, and all three attributes are marked as required, since the relationships all indicate a 1 and 1, optionality, cardinality. Moving down one more level, we have one remaining entity, from message person. It is the only entity that is dependent upon a Level 3 entity. The final entity, from message person, in our logical data model is also composed entirely of inherited foreign keys from the entities, organization, and message person. Again, these attributes need to be refreshed with the updated names. All string data types are inherited, and all attributes are marked as required due to the 1-1 notation on their parent relationship ends, as shown. And with that, the team has completed their update of the logical data model to meet the modeling standards. The team will now publish the data dictionary for their model, which will include the entity and attribute definitions. With this major milestone reached, the next step will be to work on generating the physical data model, which will be covered in the next video.
Thanks for watching.